Hello. Well, regular viewers of this channel, of which there aren't an enormous number, will be aware that I bought a Harrison M300 lathe about 2 years ago and have spent almost 2 years refurbishing it in various ways. This was something that I never really intended to do, but something that I slid into more or less by accident. When I first bought the lathe, I didn't have three-phase electrical power for it, so I thought, well, while I'm making arrangements to get that, I might as well take the lathe apart, clean it, and do whatever appears to be necessary. And that process then escalated until I took the whole thing completely apart and sought to fix various problems, and this resulted in a whole long series of videos about that. It wasn't really what I was intending to do. I just wanted a lathe that worked. The main problem with this lathe is that the ways are excessively worn, and this irritates me. As a physicist, I keep measuring things and thinking, well, that's not right, it shouldn't be like this, and it bugs me. It's difficult to cut anything straight on this lathe, and cutting anything of any length on it is extremely difficult. I mean, you can turn between centres and you can play about with moving the tailstock left and right in the hope of removing any taper that is inherent in the ways, but it's very much a hit and miss business which only works for a workpiece of a given length and is by no means satisfactory. So what I'm going to do in this video is just go through what the current state of the lathe is and the various options for dealing with that, and then to ask for advice from anybody who cares to put comments below. Because of the wear in the ways, I've had to tighten the clamps underneath the saddle at front and back so that they are reasonably tight in this area here, which one normally uses the lathe in. But it does mean that if I move it, wind it back here, it gets progressively tighter and I can't really move it further back than that. The only solution to that is to have the ways reground, or the bad solution would be to file off under the bottom of the ways up this end where it isn't worn to make it match the wear here, but that would be entirely the wrong thing to do. So there's that. Then there is wear in the cross slide, and I've got it adjusted so that it is reasonably tight in this region here, but that means that when I wind it back it gets progressively tighter here. So what I should do is scrape the ways or the gib to remove that wear, so that for a given tightness of the give it is equally easy to move all the way. So I took the apron completely to pieces, cleaned it out, replaced a bush that was worn, and did some good work here making this work correctly. But there was, however, one problem that I could not solve. If we come round and look at the thing from the side, looking at the back of the apron from the side, this round feed shaft passes through an oil seal there and another one the other side, and those oil seals leak, and I couldn't work out how to disassemble that part of the thing, so I just thought, well, I'll hope for the best. But hoping for the best was the wrong answer because they leak. So nearly all the oil has leaked out of the apron. There was nothing much wrong with the headstock, but it was leaking oil, so I replaced an oil seal in the back here. And in order to do that, I had to take the spindle out, and that enabled me to discover something else, which I'll mention in a minute. But what I didn't do is I realised that there were two other oil seals in here, one somewhere down there, and one, most important one, on the input shaft from the motor on this side. And I should have replaced those whilst I had the whole thing apart. When I replaced this oil seal, the old one was so brittle and that it just broke up in my hand. And I should have learnt from that obviously the other seals will be in a similar state. But I didn't. I thought, well, least done, soonest mended. And that was a mistake because it is leaking oil from the headstock via the input shaft. So we're getting oil down here in the vicinity of the motor. And there is the worn tailstock. If I operate the quill lock, I think you should see this going up and down. That doesn't matter for using live centres because you always have the quill locked all the time, but it matters for drilling. But I've found that when drilling, it's advantageous to just sort of partially apply the quill lock, which kind of helps to counteract the wear. But the basic problem is that the barrel through which the quill slides is worn. I don't think the quill itself is worn. But fixing that would be difficult. I don't know how you do it. You could bore out the barrel to a larger size and then put a sleeve in. Or you could, somebody on the internet I found, link in description, they bored out the barrel to a larger size and then made a new larger size quill, including engraving all the lines and scale on here, which was a massive undertaking. What he's got here is a jury-rigged tailstock mounted on the carriage. The tailstock that he wants to bore out, mounted on its own ways and just clamped in position. And then there's a boring bar running through here, driven by the chuck, but able to slide through it, as you'll see if I just run it on a little bit. He's going to have a tool in there rotating to bore that out. And because the tailstock is actually on the ways, it's guaranteed to produce a hole or a bore in line with the spindle axis. That only works, of course, if your ways aren't worn. I don't feel confident that I could do either of these things on this lathe to a satisfactory degree of accuracy. So it's more a case of living with a worn tailstock. When I removed the spindle in order to replace an oil seal in the headstock, I discovered that the outer race of the main spindle bearing, the one at the front, had this damage on it. I can't tell you what that damage is, despite studying various damage analysis brochures from Timken and SKF, but it doesn't look good. It might be due to lack of lubrication or water in the lubricant. But whatever it is, it doesn't seem to be causing me any problem at the moment, but it's something that ought to be dealt with. The problem is that the cost of a new replacement bearing would be £976, and that's a hell of a lot of money. It's possible that I could get a standard bearing from SKF or Timken that would be cheaper and perhaps not a great deal less precision than the gamut bearing, but who knows. Going back to the main problem, which is the excessive wear in the ways of the bed, I've made numerous measurements of this, and I'll put a link in the description to the videos about that, but just summarising two of them. In this setup, I've got the DTI running on the tailstock on the theory that the tailstock ways would be less worn than the main ways, and I'm measuring the wear on this slope of the front V-way. The big divisions on this DTI are 20 microns apart. Just watch how fast it goes down. This is another way I did the measurements using a V-block that I made that's effectively the same as the saddle resting on this V-way, so that one could measure the vertical movement of the saddle downwards as it goes onto the worn section. My best estimate of the wear in the front V-way is shown here. The x-axis is distance from the headstock in millimetres, and this is wear in the vertical dimension, starting at 0 at 700 millimetres from the chuck, and going down to a worst case of 322 microns, or 0.3 millimetres, just in the area where one wants to work, close to the chuck. So to summarise the problems, there are 2 oil seals in the headstock that need replacing, 2 oil seals in the apron that need replacing. There's a worn cross slide that needs scraping in, and ideally the main spindle bearing needs to be replaced, although that's expensive. Now I could do those 4 things without too much trouble. Finally, however, there is a worn tailstock which is hard to fix, and there is too much wear in the bedways. And that can only be fixed, really, by having the ways reground. So I was wondering if there was some way that I could fix these worn bedways without actually paying to have them reground commercially. Well, there's a guy in the States called Steve Watkins, the guy on the right in this picture, and he has a Monarch 10EE lathe, which is a high precision tool room lathe of a slightly older vintage than my Harrison. Actually, it's a friend of his who bought it without realizing that the ways were seriously worn. And Steve is planning to try and fix those without sending the bed out for regrinding. Let me just let him explain what he's planning to do.
This is going to go on bolt on the side of a Monarch 10EE lathe, and it's got a hardened bed, and I don't want to tear the whole thing apart, so I'm trying to come up with a system of bolting these rails to the side, perfectly aligning them, and then putting a heavy trolley cart with a grinder on it and an indicator base. Yeah. So you can measure as you go. Okay. And you don't have to tear the whole thing apart. If it works, save himself a lot of trouble. Yeah. It doesn't work, yeah.
Well, Steve has a massive workshop with a big planer with an 8-foot table, so that he's able to take these castings and cut them flat within a thou. And his idea is that rather than just grinding the ways flat in one go, he will take the same approach as scraping. That is to say, he'll do a bit of grinding, then use a long straight edge to test how flat the ways are, and where he finds that they aren't, do some more grinding. And that, I think, will work, but it's not an approach that I can adopt, because I don't have a massive planer, and I don't have a big surface plate, and I don't have long straight edges. And if I bought all those things, I could buy a new lathe with this for the same money. So that's an interesting approach. I will put links in the description to his videos about that. He hasn't by any means got any further than these castings at the moment, but you can follow that up if you wish. I have discussed this with the only firm in Britain that I can find that will do this kind of job, and they would require the bed and the saddle, and they would regrind the bed and also grind the saddle and build it back up with turkite so that the saddle is at the same height above the reground ways as it was before they reground them. This is necessary because if you regrind the ways without doing that, then the saddle is lower and therefore it interferes with the correct alignment of the shafts that go through the apron to the feed gearbox. I'm kicking myself because there was a time when I had the bed and the saddle completely loose and I could easily have popped them in the back of my Shogun and driven up the M1 to the Midlands and got this thing reground. But now I'd have to take the whole lathe apart again, and that a bit rather sticks in my craw. Second option is to buy a better M300 off eBay or from a commercial dealer. I actually paid £2,500 for this M300 that I've already got, and I definitely overpaid for it. I would not have paid that amount had I realised how worn the ways were, but my superficial examination of them did not reveal how worn they were. I reckon, having studied eBay advertisements, that one would need to pay between £5,000 and £6,000 to get an M300 whose ways were not badly worn. So that's one option, but I would then have to get rid of the M300 that I've got. I believe the scrap value is about £500. I could sell it on eBay, but that would not really be honest unless I said, well, the ways are badly worn. And if the ways were badly worn, why would anybody buy it? Perhaps the best way of disposing of the M300 I've got would be to break it and sell the parts individually on eBay. That way I'd probably recover my initial outlay on that lathe, although it would be quite a lot of bother. Of course, I had to get the M300 out of that workshop and down the step again, which would be another palaver. But at least I would have an M300 that I was happy with at the end of it. On the other hand, I put so much effort into refurbing this one that it goes against the grain to throw it away now. Another option would be to get this G330 ES lathe from Gate Machinery. This lathe spec is very similar to the Harrison M300. The Harrison has a swing over bed of 330mm and a distance between centres of 630mm, and this one has the same swing and only distance between centres of 600mm, about the same. It's quite well specified, and interestingly its weight is within 4 kilograms of the weight of the M300, so that gives some assurance that it will be just as rigid as a Harrison. This lathe, including VAT, cost about £15,000 in 2021, and I did actually consider buying it instead of buying the Harrison. But although I could afford to buy it, being immensely old and owning my own house and having paid off all my debts, unlike poor young people of today who are saddled with university debt and can't afford to put down a deposit on a house that they desperately need, I could have afforded to buy this. But I just thought to myself, well, is it really a justified purchase? Would I put it to sufficient use to justify that outlay? And I decided against it on those grounds. Later, after I discovered that the M300 I've got has these worn ways, I actually went up and saw one of these G330 ESs in the showroom, and it is quite a nicely made lathe. In one respect, it's better than the M300 because it has an adjustment for the headstock alignment, which the M300 does not have. Although you could say that that's a mixed blessing. Headstock alignment is probably something you should leave well alone unless there's something desperately wrong with it. And there was one of these in the showroom available at a reduced price, which I very nearly bought, but in the end I let it go. There is an accuracy spec for this lathe, which seems to be pretty much identical to the spec for the Boxford lathe. Maybe it's a standard spec for all tool room type lathes. But looking at the thing at the bottom here, which is most practical, it says accuracy of cylindrical turning 25 microns over 300 millimeters. Well, that's about just under a thou over 300 millimeters, considerably better than I get with my M300 at the moment. This gate lathe is made in Taiwan, and one of the reasons I thought of getting it is because Adam Boove of YouTube channel ABOM79 recently bought himself a Precision Matthews TL1660, which he said was very nice and very accurate. And I was looking at it, and then I looked at its little brother, and that one I think is almost exactly the same as the Gate G330 ES, except that this is, I think, is a longer bed version. There is a longer bed version of this one as well, but they looked exactly the same. So evidently they're made by the same Taiwanese manufacturer. It doesn't prove that they're made to the exact same spec, but it gave some comfort that it wouldn't be too bad a machine to buy. Or I could buy a brand new M300 from the 600 group. This quote was given me in May this year. Doubtless the prices have gone up since then, including VAT. That takes it to about 19,000. But it would have the advantage of being a lathe that I know and understand, and where I could transfer some of the accessories that I've got onto it, probably. I'd have to check that. And finally, there is the option for me to stop moaning and live with the lathe as it is. That's hard for me to do, being a physicist and constantly measuring things and not liking the result. Right, so there you have it. Everything that's wrong with this lathe and my choices for what to do. I don't know what to do. So my hope was that in the long, dull, damp days after Christmas, when people have nothing to do except talk to their relatives, maybe some of you could think about this and let me know what I should do by putting something in the comments below. And I wish you all a very happy Christmas and hope to see you next year.